In this video, we are going to talk about vectors and vector quantities. Now, suppose that we have a square with the sides being 2 centimeters. Now, to calculate the area, all we have to do is multiply the adjacent sides 2 times 2. And this is 4 centimeters squared. Well, when it comes to quantities, this is called as a scalar quantity, because we only know about the number, the amount, and here for area we know that it is 4 centimeters squared. But for vectors, we should have, the number as well, but we should also have a direction. So we define vectors as a quantity that has both magnitude, meaning the number, the amount, and direction. Vectors are represented with a line segment which one of the tips has an arrow, as seen in the example. So we have an initial point and a terminal point, and the arrow tip here shows the direction of the vector. Well, as we're talking about initial and terminal points, these points have coordinates, like say x1, y1, and x2, y2. So this means we are talking about two-dimensional coordinate plane. So the same vector represented here by A can be anywhere in the coordinate plane. You can have the same vector here, you can have the same vector here. It doesn't matter, as long as you define the initial and terminal points, and since the points would be the points will be different, but the direction and the magnitude of the vectors are the same. So regardless of where the vector is, this is the same vector. So since we have the same vector wherever we put it, then we can have the same vector starting from the origin, the same vector A. So in that case, we have the same vector in standard position. Now the advantage of standard position is you can only define the vector by its terminal point, and also you can define the direction of the vector by the angle between the vector and the horizontal. And the line segment here, which we use to represent vectors, the length of this line segment is called as the magnitude of the vector. Let's look at the vectors here. Now, we have parallel vectors with the same direction, but not necessarily the same magnitude. So examples are, for example, A, B, and C. So here A and C seems to have the same magnitude, but not B, where all of them are parallel. Equivalent vectors have the same direction and same magnitude. Example for equivalent vectors in A and C. They have the same direction and they have the same magnitude here. And we have the opposite vectors. Well, opposite vectors have the same magnitude, but the direction is exactly the opposite to each other. An example to this may be A and E. They have the same magnitude, but they show the opposite direction. Now let's talk about how to distinguish vector quantities and scalar quantities. Let's see an example. Now here the question says, state whether each quantity described as a vector quantity or scalar quantity. Now, if it is a vector quantity, it should have magnitude and direction. So, in part A, it says a boat traveling at 15 miles per hour. Well, this is only the magnitude, there is no direction shown in here. So, this is a scalar quantity. In part B, we have a hiker walking 25 paces due west. Well, this is the magnitude, and this is obviously a direction. He is going to, of course, not that direction, which is west. So we have magnitude and we have direction. We can say this is a vector quantity. How about a person's weight on a bathroom scale? Well, this is a kind of tricky question because weight can be seen as a scalar quantity because on the scale we only see our weight. But the thing is, weight is dependent on gravity, which is a downward force. So it has a direction. So weight is the magnitude, the number we see on the scale is the magnitude, and since it depends on gravity, it has a direction downwards, so weight is a vector quantity. Now is your turn. Determine whether the given quantities here are vector quantities or scalar quantities. Please write your answers on the answer sheet as vector or scalar.